This is a video about to study about the how to calculate the support reactions. So in the last video class we have studied about type of supports. So just brush upping, the supports are mainly of three types. First one, it is a fixed support. Next one, it is a hinged support, and the next one, it is a roller support. That is this one hinged and this is roller support. And based on this we have studied about many type of beams. Now based on that is fixed beam, simply supported beam, the cantilever beam, overhang, and then continuous beam, etc. So mainly now let us consider what are reactions. We have to know what are reactions. So in a two-dimensional space, that is in a XYZ plane, that is I have said always, we are always considering XYZ plane. So in a XYZ plane, there the possible movements are, it can move in the vertical direction, horizontal direction, and there can be a moment. That is, movement can be in the X direction, Y direction, and moment. Now if we are having a support like this, having a support, this is a fixed, this is a free support, and this is a fixed support. Okay. Now each point, any point in a frame, any point in a two-dimension frame can have three types of movements. You have to clearly listen. Any point, that is this point or this point, can have three types of movements. That is, it can either move in the vertical direction or in the horizontal direction, or it can rotate. Okay, or it can rotate. So this point, there can be a vertical, can horizontal, and a movement is permitted. But in this case here, it is a fixed support. Here the possible movements are these ones. But due to fixity, what is going to be fixed support? It will not allow any type of movement. That is, vertical movement will not be allowed, horizontal movement will not be allowed, and rotation will not be allowed. That is, all these are not allowed. So in any body, if the movements is not allowed, that is, if this body is trying to move, the fixed support will automatically fixed support will not allow in the movement. So reaction will happen. The reactions will happen when we are resisting the motion. That is, for a two-dimensional body, in a space, at a, this is a support. Okay, this is a support. So at a support, there can be three reactions. The reactions are, that is, there can be a reaction, there can be a horizontal reaction, there can be a vertical reaction, and there can be a moment. Okay, these are the three possible types of reactions. Okay, now in a fixed support, at this point there can be these three reactions. But in the case of a hinged support, this is a hinge one. That is, here we have hinge one. The possible movements are vertical, possible reactions are vertical, horizontal, and moment. Possible reaction. But in the case of a hinge, I have said that hinge support will permit a rotation. That is, this rotation is permitted. That means, since this rotation is permitted, therefore there is no moment. In a hinge support, the moment is 0, but there is a vertical and horizontal. Now in the case of a roller support like this, it can have a vertical reaction, a horizontal, as well as a moment. But in the case of a roller support, it is permitting the motion. Here the roller support, that is, it is allowed to move and it is allowed to rotate. So in this case, in this case only, here vertical and horizontal will be there, moment will not be there. Here again the horizontal reaction will not be there, and moment also will not, moment will be 0 Here the moment will be 0, and here also the horizontal reaction or RV or RH, that is equal to 0. There will be only RV, that is vertical reaction. Here there will be vertical and horizontal. Moment will not be there. So in the case of a fixed beam, it is, in the case of a fixed beam, there will be a horizontal, vertical and moment. There will be horizontal, vertical and moment will be there. Here there will be, in a hinge beam, there will be no moment will be there, but there will be a vertical and horizontal reaction. So what is meant by, so now let me explain about what is really reaction is. Reaction means if there is a body is there, if some body is resting, okay, at a place, I am pushing that body by some force. I am pushing that body by some force. If the body can move along one direction, if the body can move, it is allowed to move in this direction, then that means that the horizontal reaction is 0. But here I am the weight of the body is there. The weight of the body, as you all know, if the ground is firm, it will not, the body will not go down. That is, that means how the weight is balanced, there will be a vertical force. That will be equal to W. Okay, that means reaction means if we are resisting a type of movement, what are the movements are allowed? That is a vertical movement, horizontal movement and rotation. So if we are resisting any of the movements, any of these three movements, then the reactions will happen, reaction or moment will occur. Okay. That's why in a fixed beam, what is the condition of this point? There will not be any movement. Therefore, here there will be vertical, horizontal and moment. But in the case of hinge, there will be vertical, horizontal but no moment. And the roller, there will be only vertical. The moment will not be there. Okay. So far there are three types of supports. So let me explain about the equilibrium condition. So this is the things which we have discussed now. Now let me that is here, that means in a fixed beam there will be horizontal reaction, vertical reaction and moment. In a hinge beam there will be vertical and horizontal, moment will not be there. Hinge support. Then a roller support, there will be only vertical in the case of a horizontal roller. In the case of a vertical roller, there will be only horizontal force. Okay, the vertical and moment will be 0 at this point. Okay, now equilibrium condition. So for a body in XY plane, that is in two-dimensional plane, for any point or any body to be in equilibrium, let this be a body. This body have to be in equilibrium when the sum of the horizontal forces is equal to 0. Sum of the horizontal forces acting should be equal to 0. Sum of the vertical forces should be 0. And sum of the moments should be 0. So, in the case of a two-dimensional body in the XY plane, the sum of the horizontal forces, vertical force and moment should be equal to 2. So, to be specific, that is, all the forces in x direction should be 0. All the forces in y direction should be 0. And the moments in the xy plane should be 0. So this is the equilibrium condition of a two-dimensional body. Okay. Whereas in the case of a three-dimensional body, that is a body, it is resting in the three dimension x, y and z. Here the sum of the forces in the x direction should be 0. Sum of the forces in the y direction should be 0. Then sum of the forces in the z direction should be 0. Okay, that is z direction, it should be 0. Now the sum of sigma m x y should be 0. Sigma m x z should be 0. And sigma m y z should be 0. That means here for a two-dimension body there will be three equilibrium equations. here for a three-dimensional body there will be 6 equilibrium equations. Okay, there will be 6 equilibrium equations. Okay, that is fx, fy, fz, mxy, mxz, myz. Now this is a general case of a 3-dimension and 2-dimension. So we will be dealing with this one. So our topic will be now to find out the reactions. So now let us find out. We know that a simply supported beam, it is mainly, simply support is mainly expressed in this way. Okay, so we know that at a fixed support there will be this is a hinge support. This is a hinge support. There will be a vertical reaction. There will be a horizontal reaction. Here there will be only a vertical reaction. So here let it be A and B. So here there will be an RA. For example, let it be VA. This is VB and HA. Horizontal reaction. So in the case of a simply supported beam, it will be like this. Simply supported beam, it is also SS beam, like that also. Sometimes we are conic. So simply supported beam. So if your question will be raised is find out the find out the reactions of a simply supported beam. That means we have to find out what are the conditions. Now this can be asked in another way also. For example, mainly you will be asked to find out the reactions of simply supported beam and overhanging beam, like this. Overhanging beam, or it can be a double overhanging beam also, single overhanging beam and double overhanging beam. So these 3 problems will be asked. Okay, now because mainly the structures are divided into, this is a very important thing, mainly the structures, that is structures are divided into 2, that is determinate and indeterminate. Determinate and indeterminate. Determinate and indeterminate means, that is, for example, here in a simply supported beam we have to find 3 unknowns. We don't know what are the 4 reactions. That is, here in a beam there can be 3 types of load. One is a point load. This is a point load. Other one, it is a last class we have studied. This is a UDL or uniformly distributed load. Another type of load, it is UVL, that is uniformly varying load. So this one only which I have explained the last, that is, if there is a beam like this, I have drawn a figure, we have shown the figure. This is uniformly UDL, uniformly distributed load, UDL. Okay, and the unit is kilonewton per meter or Newton per meter. Okay, but in the case of a UVL, in case of a point load, it will be in only Newton or kilonewton, like that. So for example, a beam is like given, there will be some loading condition. I will explain about the loading conditions much more, but now let us focus on some loading condition is given, any load it be. So in any load condition there will be 3 reactions. Maximum possible reactions are 3. It is sigma HSA, VA and VB. That is, we have to find 3 unknowns. Okay. Now the last so I have explained that in a 2-dimensional figure, that is what the conditions in a 2-dimensional plane, we have 3 equilibrium equations. That is, sigma H is equal to 0, sigma V is equal to 0 and sigma M is equal to 0. So we are having 3 equilibrium equations. Sigma H is equal to 0, V is equal to 0 and M is equal to 0. So in a simply supported beam, I have to find 3 unknowns and I am having 3 equilibrium equations. Therefore I will be able to find the all the unknowns. That is, if I have two unknowns, let it be, if I have to find x and y, then how many equations I will need? I will need two equations. If I have x, y and z, I have to find. Then how can I find out? I must need three equations. So if I am having three unknowns, I will be able to find the three equations. Three unknowns. Then if I have three equations, then I can find that. So a structure where the number of unknowns is equal to the number of equilibrium equation. Number of unknowns is equal to equilibrium equation. Then if that both are equal, that is known as a determinate structure. Indeterminate means, for example, here let us consider a fixed beam. Okay, fixed beam. There can, in a fixed beam, at one point there can be three unknowns. Here also there can be three unknowns. That is total. Here 3, plus that will give us to 6. So we are having 6 unknowns. But in the case of a 2D frame, what are the possible equilibrium equations? Only 3. That is, sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. Only. So 6 are there, but 3. That is, we are having 6 unknowns, but only 3 equations. Therefore 3 is extra. Only 3 unknowns we can find out. So a structure where the unknowns is greater than the available equation. Here unknown is equal to the available equation. Here the unknown is unknowns. Unknowns means what are the, here the reactions is greater than the available equilibrium equations. Then that structure is known as a indeterminate structure. Okay. So structures are divided into two, determinate and indeterminate. Determinate means number of unknowns. Number of unknowns means, here means it means reactions will be equal to. That is, we can find out the reactions by using equilibrium equations. What are the equilibrium equations? Sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. Now, if the number of unknowns is more than our equation, that is a indeterminate. So in your particular TOS 1, this subject, we will be dealing with determinate structures only. Okay, we will be dealing with determinate structures only. Determinate structures, what are the possible determinate structures? Structures here means beams. In the first module it means beams, only beams. So we have to find out the reactions of, first one will be a simply supported condition beam. That is this one, a simply supported beam. Okay. Next one, here it will be a cantilever beam. Cantilever beam, here there can be this is a fixed support. There can be a vertical reaction, horizontal reaction, and a moment. Here there is a free end. There will not be any reaction, because this end, why there is no reaction? This is free. This end can move in any direction. It can rotate, it can move in horizontal and vertical direction. Therefore there will be no reaction, because there is no support. But here there is a fixed support. That is, this is known as a cantilever beam. So here the number of unknowns is 3, and number of available equation is again 3. Therefore it is same. So this is, so we have to, first one we have to find out the reaction in a simply supported beam. Second one we have to find the reactions in a, we have to find the reactions, or we have to draw the bending moment and shear force diagram like that. So mainly in our TOS 1 we will be dealing with one simply supported beam, then cantilever beam. Next one it will be a overhanging beam. So overhanging beam, the types of support can be anything. It can mainly in your case the overhanging beam will be having a condition like this. That is, there will be a hinge, there will be a roller and a overhang. Or it can be in another way, that is, there can be a hinge and roller. Okay. So this is a single overhang beam. This is a double overhang beam. Okay. So these are the So these are the questions which will be asked. You have to find out the reactions. That is a simply supported beam, a single overhang beam, double overhang beam, and cantilever. It is mainly we have to the cantilever, the reaction. It is easy, but water force is coming, it will be the reaction. So I will explain that. So these are the four, mainly these three are will be asked for. How to you have to know about in this particular module. So so here we have to find out the reactions, support reactions in a simply supported beam, in a single overhang beam, in a double overhang beam. Okay. So far I have discussed about the. So far I have discussed about the. So far I have discussed about the first one. I discussed about the type of support, that is a fixed support, hinge support, and a roller support. So fixed support, it is having possible reaction is 3. For a hinge support, the possible reaction is only 2. Moment is permitted, therefore the moment there will not be any moment. Now in a roller support there can be 2 types of rollers will be there. We will be mainly dealing with the another type of roller will also be there, that is sometimes it will be in an inclined way, like this. Inclined way, a roller can be in this way also. That means here only one reaction will be there in this direction. Here in this horizontal direction, since it is permitting the motion in this horizontal, that is whenever we are resisting a motion, there will be a reaction. If it is freely allowed to move, then there will not be any reaction. So that is the reason why these type of supports are being generated. Okay. Then in order to find these reactions, we need some equilibrium equations. So that equilibrium equations are in 2 dimension. We will be having 3 equilibrium equations. That is, forces in the x direction should be 0, forces in the y direction should be 0, and for moment in the xy plane will be 0. Now, in the case of a 3-dimensional figure, there will be 6 equations. Fx, Fy, and Fz should be 0. Mxy, Mxz, and Myz will be, that is 6 equations. 6 are there. Here there is 3 equations. So we will be dealing with 3 equations only. So these are the things which we have studied so far. Now let me explain about the loads which I have given in the last class. So loads. So loads means there are 3 types. One is a point load, then point load. Second one is uniformly distributed load, and third one is uniformly varying load. Now a point load means it is acting at a point. Okay. Now you have to be very clear, that is last in the slide I have explained, mainly the figure was given like this. Okay. UDL. So in textbooks we are representing this in another way also, like this also. Okay. This means UDL. These both are same. Okay. Here it will be given in some force, some number in kilonewton. That is, this force is acting throughout the beam. Here it will be same. Let it be 10 kilonewton. So this is the representation. It can be Newton also. Here only in kilonewton. Then another type, it is the UVL. That means we will be having any support. I am not telling about the supports. That is, we will be if nothing is given. For nothing is given, that is support condition. We know that 3 supports are there: fixed, hinge, and roller. So if only an arrow is given, sometimes you will be representing by only arrow. That means there will be only a vertical reaction. Okay, that is, there can be supports are mainly given in this way. You know that. That if it is given, there can be a vertical and horizontal. Moment will not be there. But if sometimes we will be representing with the beams like this only. That means only if only one arrow is given, that means it is only having vertical reaction. So it is mainly simply for representation we are mainly using. And in the our normal cases we will be dealing with such type. So UVL we were explaining. So UVL will be in this way. Okay, this is UVL, and some kilonewton per meter will be there. Some kilonewton or Newton per meter. Now let me now let us take an example. Okay, let us take an example how to find. So we are given with a simply supported beam. Let this be the beam, simply supported condition beam. A beam is given. It is acted upon by a force of 10 kilonewton and the lengths are given. Let it be at the 2 meter respectively. That is, the total length of the beam is 4 meters. Okay. Now before going into this, why we are really telling about why we are finding the reactions in a beam? Because I have explained earlier, that is when I am drawing a building, for example a 3-story building. Okay, this is just a representation. 3-storied building. Okay, here there is a beam, here there is column, this is a column, then let it be a then 3-story. Okay, 3-story building, and I am showing only one view. Okay, so in this beam, for example this beam, the force can be due to what all? There will be a, sometimes it due to brick or any stacking of any material or anything, or due to the sulfate or due to the slab. There will be slab. The slab load will come into, first one will come into the beam, then this load will come into the column, and then this will come into the footing and last to the soil. Therefore, so if we know the force, if know the reaction, here what will be the, here there will be a force. It can be point force, UDL or anything. So this force will be distributed, it will pass like a horizontal force till to the end, and then it will pass to the ends, it will become a vertical force. So in order to know what is the force coming in the column, we have to find the reactions. If we know that, we can design this column. Design. So designing a column means to find out this dimension, what should be the column should be, what concrete it should be using. That is the meaning of designing. So I am not explaining that in that way now. So we have now a simply supported beam is there. Simply supported beam is there. Then it is acted upon by a 10 kilonewton force. Then 2 meter and 2 meter. That is, the total span is 4 meters. This is our question. Let it be A and B. Okay. Now, in this case, at this point, the possible reactions are, there can be a vertical reaction, there can be a horizontal reaction. Here, for a roller support, since this is a horizontal roller, therefore there will be only moment. Therefore, the possible reactions are vertical. Here there can be a vertical A, VA, there VB and HA, horizontal reaction. HA, you have to be very clear when I am saying. So the possible reactions are VA, VB and HA. Okay. Now these are the possible reactions. Now if a reaction have to happen, there should be a load. So let us look the load. There is a vertical load. Okay, very clear. You should be very clear. There is a vertical load. So due to a vertical load, what type of reaction it will be having? Only vertical reaction. This horizontal reaction will be there only if there is a horizontal load. For example, there is a beam like this. The same beam having, and a 10 kilonewton is acting like this in a vertical at an angle 30 degree. Then then we know that that is, for a slanting force there will be a horizontal force and there will be a vertical force. So if there was a slanting force, there would have been a horizontal force also. That is horizontal one. So if that is the number of reactions first on a real beam, which you have to find out, depend on the number of reactions on a beam, depend on the type of force in that beam, depend on the type of force in that B. So in the given beam, there is only vertical force. Therefore, this horizontal force will not be there, because there will not be any horizontal force, horizontal reaction there, because there is only vertical force. Therefore, here the reactions are the vertical reaction at A and vertical reaction at B. So these are the two possible reactions. The horizontal reaction at A is not there. Why? Because no horizontal force in the beam. Only a vertical force is there. Okay. So we are having VA and VB. Now, so we are having two unknowns. In reality, what we have, that is in 2D frame, we will be having three available equations. That is sigma of all the vertical forces. Let it be sigma of all the vertical forces should be 0. This is one equilibrium condition. Second equilibrium condition is sigma of all the horizontal forces is 0. And third one, moment should be 0. Okay. So these are the equilibrium conditions. So we are having three equilibrium and two unknowns. Now let us take into this example, that is, let us take, so three equilibrium equations are there in that is in the general case, but here we are having only a vertical force. There is no horizontal force. Therefore, this equilibrium equation cannot be taken, because in this whole structure there is no horizontal force. Therefore, we cannot use this equilibrium. So we can only use these two equilibrium equations to find out these two unknowns. Okay. So since no horizontal force is there, so no equilibrium condition for horizontal force can be taken. So now, so we are having two, that is sigma FV is equal to 0, and that is a vertical force should be equal to, and moment should be equal to 0. Now for a hinge support, this is for a simply supported beam. For a simply supported beam, this should be clear. Here, what is the here the possible reactions are here. What will be the moment? What is the moment at A? Because it is a hinge. Hinge will permit the moment. Therefore, the moment at A will be 0. That is a condition. Moment at A will be 0. Then what about B? B, there is only vertical reaction. The horizontal reaction and moment will be 0. So moment at B will be 0. So this sigma MA, that is moment, is mainly expressed at a point. That is that we have told in the moments when you have said, that is moment about a point is always taken. So moment about this, so in this equilibrium condition we are having two cases, that is sigma, that is the total moment, that is a total moment about A is equal to 0, and also the total moment about B is equal to 0. I will, as we do the problem, you will be more clear. So moment about A and moment about B will be 0. Why this is 0? Moment about A is 0 because it is a hinge support. Moment about B is because a roll support. In the roll support there will be only a vertical reaction if the roller is horizontal, and here there will be vertical and horizontal reaction. There will be, or maybe, but here only, since no horizontal force is there, there will be only vertical reaction. So when we are first of all analyzing a structure, we have to find the reaction. First of all, you look at what are the supports. So here this is the two supports. So you have to first of all understand there can be a vertical reaction and horizontal reaction. Here there can be only a vertical reaction. Now look at the load. Since only a 10 kilonewton load is given here, that is vertical, no horizontal force is there. Therefore, there is no horizontal force. Therefore, this horizontal force, if no horizontal force is there, there will not be any horizontal reaction. That is, if a horizontal force is there, it will be moving in the horizontal direction, and there will be a reaction. But since no horizontal force is there, there will not be any horizontal reaction. So when we are giving a force to a beam, at the supports there will be, it is opposing it. That is known as reactions. Okay, if I am giving a 10 kilonewton here, this 10 kilonewton have to be supported by these two supports. Otherwise, the beam will fail. So, what are the forces coming at these supports, it is known as the reactions. Okay, that is a real case of, that is a real meaning of reactions. Now, so we are having these are the two equilibrium. So moment about A, and so a simply supported beam, the moments at the ends should be 0. So now we have to find two equilibrium. Let us take the first equilibrium condition. Sigma Fv is equal to 0. That is, sum of the vertical forces 0. So let us draw the figure once more. This is the beam. A 10 kilonewton is there. Now I am changing the supports into forces. Here, because there is only vertical, so I am changing that figure. There is Va and Vb. So from this vertical forces, what are the vertical forces coming here? That is Va plus Vb. Another vertical force is 10, that is acting downward. We can write 10, that is equal to 0. That is Va plus Vb is equal to 0, is equal to 10. That is the first equation. Okay, we have got. Now second one, moment. Another equilibrium equation is moment. So two unknowns, and second one we can take either a moment. We can take moment about this point or moment about this point. So let us take sigma moment about A. So that means we have to first draw the figure. Okay. There is 10, there is Va, and this is Vb. So let us take the moment. So this is the point. Okay, this is the point. This 10 kilonewton, this is 2 meters, and this distance is 4 meters. Okay, that is given here. Total distance is 4. Now I am taking the moment from this point. Okay, now look, 10 kilonewton is acting here, and moment means force into, this is the force into the perpendicular distance from the force to the line of action. This is the line of action. So this is the perpendicular distance. So moment due to this force will be 10 into 2. And how it will be? It is in the, look at this. If I am holding here, holding a pen here, 10 kilonewton is acting. So it will be rotating like this. So this direction, it means it will be clockwise. So the moment at that point will be 10 into 2. So we are developing the equation, that is sigma ma should be equal to 0. So about A we are finding the moment. Okay. So let us first be clear that in this whole about E, when we are considering in this figure, there are three forces now. That is a 10 kilonewton is there, Va is there, Vb is there. So when we at point A, the moment, first one we have taken, at point A there is a force Va. Va is there, but it is acting at the same point. Then what is moment? Force into perpendicular, that is a perpendicular distance is same. That is first one it was Va. Va into 0. Okay, because there is nothing, no force is, no distance is there, so you don't have to write this. Okay, if you are taking at point, if any force is there, don't take that. So 10 into 2. Now next one it is Vb. Vb we have to find. So Vb, it is acting in the upward direction. So we are considering it is acting in the upward direction. So it is moving in the anti-clockwise direction. Therefore it will be minus Vb into 4. That is Vb is acting here, and this is the perpendicular distance. This is the line of action of this force. This is the perpendicular distance, that is 4 meters. Minus Vb into 4 is equal to 0. Therefore so we can write Vb is equal to 20 by 4, that is equal to 5 kilonewton. Simply this will be equation number 2. Now substituting 1 in 2, substituting the first equation in 2, we will be getting Vb. So here Va. So Va is equal to 10 minus Vb, or that is equal to 5 kilonewton. Therefore we have found out Va, vertical reaction Va and Vb as both are 5. Okay. So this is the way in which we are finding the reaction. So this was the given question. So there it was having a simply support. So first of all we have to look what are the supports. Here there is a hinge support. Here there is a roller support. Therefore here there can be a vertical reaction and horizontal reaction. Here there can only be a vertical reaction. So the unknowns are vertical, Va and Vb only. Now the available equations are sigma Vf, vertical force should be 0, sigma of the whole vertical horizontal force should be 0, and moment about a point, okay, should be 0. So since horizontal forces is not there, therefore this condition cannot be taken. Therefore we can take these two conditions. These conditions can be taken. So first of all we take the sigma V is equal to 0. So this is a beam. Just write our notations. VA and VB 10 kilonewton. So VA plus VB is equal minus 10 is equal to 0. It is this in the upward, that is the downward. For just I'm using the sign. So VA plus VB is equal to 10. That is the first one. Next one, it is the moment about any point. That is for a simply supported beam, moment about this point and moment about this point can be 0. Therefore I am just taking moment about A. So moment about A means, first of all, in order to first calculate the moment, we have to look what are the forces. Here there are the 10 kilonewton, that is the force which is applied. Then we have to find out the vertical and these moments about that point. That is here, first forces we have to find out VA. So VA, that is at that point 0. Then 10 into 2, that is in the clockwise direction. This is in the anti-clockwise direction. Therefore we can find VB as 5. Then substituting 2 in 1, you will be getting 5. So likewise we can find out the reactions. Okay.